Hi team, hi team, welcome back. So today we actually discussed about the remaining part of NumPy. So in this case of NumPy classes, we actually focused upon the other attributes. Okay, so we discussed this last time. We today covered. Let me showcase. Yep. So we actually covered the other functions which are of this array, NumPy array. Now these functions were like I showed how to see the documentation of any function, and then I showcase about identity function. We also discussed about the np1s, np0s, np.full. Then we talked about a library called sys and how we can actually use this library to get the component get size of. Thereafter we talked about the memory performance and functionality of numpy. We discussed like what is the storage taken in by this list as compared to a numpy array, and then we talked about the performance. We introduced a new library called time and showcased what are the properties of time. Explained that time can be used to record its starting time and ending time, starting and stop time of any operation, which can then list out the time taken by a CPU to perform that action. We created a size 10,000 element size lists and had done this operation over here. The basically the A into B operation using the for loop, and we highlighted the time taken in this much second, and thereafter we did the other part like if we do the same using an array, numpy array, it is taking considerably less amount of time, and we identified what is the speed by which. So numpy is actually processing data for 4,000 times faster than a list. And then we actually talked about numpy array slicing and indexing, and one of the functions called as array, where it can actually convert any given data point into a given list into numpy array as well. So how you can create numpy array using existing data? It can be using list, it can be using tuples as well. This we actually highlighted to the students. Thereafter we showcased one application of numpy using like opening images and actually uh, identifying the images based upon these three channels red RGB. This one is actually regarding a handwritten digits 8. Then we actually progress ahead and downloaded one nature image, which we showcased that okay, how we can actually access the individual elements and do the slicing and other details around this image array. So this is a channel 0, so red channel gray map, and channel 1 green gray map, and channel 2 blue gray map. The individual saturation or the strength of the colors inside the parent image we have highlighted, and this is all based upon a 2D image which is actually showcased over here. And then we talked about how we can do indexing and slicing. So this action is actually indexing and this action is actually slicing, which we have done. We also showcase that we can readily do the image operations just by addition, subtraction. We can actually make that effect, and we can directly see what is the effect on this image. So NumPy facilitates element-wise arithmetic that we highlighted, and thereafter we talked about the other details. NumPy slicing again, accessing individual element like this RGB pixel, and re-explain the example using the simple arrays like that, a dimensional array, two-dimensional array, three-dimensional array like this. Yeah, we also talk about transformation, and then after we actually talk about the other methods, reshape and resize. So what is the effect of reshape and resize on a smaller array like this or on a bigger array image like this, and where we can actually visualize what is happening in NumPy. So we talked about all of this, and last one was flattening the array. So np.flat, basically np.flattening is not defined in the current version, so that's why we explained the flattening by np.reshape method. So by this we actually completed what we have for NumPy over here. Okay, that's it.